So that's diodes. We got diodes down?
It's going to have to marinate a little bit.
Gonna? All right. Well, now we're going to talk about transistors. So,
Everything's marinated.
all right, transistors. Well, you already saw the video.
Okay, so don't forget to start the program.
Yeah, it's recording. There? That one? Yeah. Yeah, started it kind of early. No, you see that? Never noticed it. All right, transistors. All right, transistors. We have two types. Well, let's do a transistor. So transistors, if you remember from a few weeks ago. One of them has an arrow going that way, and one of them doesn't. We just go like that, and this. That one points in, so this is a not pointed in and pointed in, pointy, not pointed in, NPN. All right, two types, transistors, two types. Two types. We have the NPN, not pointed in, which I just said, the not pointed, nope, in. The base is P-type. So we have the base is right here, base. We have the collector and the emitter. Same thing here, base, collector, emitter. But I made a drawing here. Where's my drawing? Let me see. Oh yeah, that was it. So I kind of made a drawing that I sort of liked. So let's take a look at the NPN. You can draw it that way. Kind of hard. It's easy to remember the little not pointed in. You can remember the thing right there is the base, the collector, emitter. I'm not too worried about. But one day I kind of came up with the idea of, what if I drew it like this? N, P, N. Like, whoa, that kind of starts to make sense in my little head. There's my base. There's the N's. There's the P. We're kind of going to look at that in a little bit. Maybe make that our drawing. And because when you look at it this way, we're going to talk about how they work, I can kind of take a look at it and say, well, shoot, that right there is just an N and a P. What is that?
Diode.
It's a diode. And this is another diode. And it was right about this point when I came up with this and I explained it, and everybody goes, yeah, it makes more sense. And then some electrical engineer goes, yeah, it's not true. I'm like, whatever. It's not, so it's not true, but it'll help you figure out how they work real easy. Base is the P-type. Well, then the collector and the emitter. Collector and emitter are the N-type. And there was something, I probably could have stopped it here. Let me see. Let's go. Can't really play it, but let's do this.
Is a negative G and will.
I was hoping
Now, let's
for-
connect the second power supply as shown. The power supply should have enough voltage.
Well, there was a scene in here I thought, oh man, that'd be a really good thing to stop and talk about, and then I didn't. Where it showed N and P type. Maybe it was this one. No. Let's see. Yeah.
Are you talking about the end to P?
Where it
and
said,
P
yeah,
to the
collector,
right to the
emitter,
left?
and it had everything. Let me see if that's it.
Ensures that no remaining electrons flow to the positive terminal of the second power.
There it
The
is.
collector current will increase.
There. All right. So, let me see. Close captions. Get that off. Turn off the ads. All right. So, I was just thinking about this as we were watching. Like, oh yeah, I gotta remember this. So we have the base, the collector, the emitter. But notice which way they have it shown. So I don't think I can. I think if I make it go big screen, it'll start at the beginning. Let's find
Oh,
out.
you're at 5:30.
Yeah, I was gonna say 5:30. Thanks. Wow, that just.
You can easily see that the transistor is essentially two diodes. This is a clear case of current
Clear case. All right. Thank you for the ads. Turn that off. All right. The point I was going to make is back up. There we go. Thank you. Notice which way the current is going. I hate that. They're showing it. Well, they're showing it in reverse, which is kind of helpful. So the gold copper top, that's the plus, and so they are showing it with.
increased proportion.
Yeah, the arrow going one way and the electrons going the other. Follow?
This is a
So the collector is emitting out electrons, and this plate is collecting them, and that says emitter, which can make you go a little crazy. But that sort of speaks to the period of time in which I think this was all created, when it was more of a, and this is me making up shit, when it was more about not electron, but conventional. So if you look at it conventional, then it would make sense where the positive is the collector and it goes in the positive and it comes out the emitter, but it's backwards. So, yay. Does that make,
So it collects and collect.
so the collector doesn't really collect, it emits, and the emitter doesn't really emit, it collects.
Given
And
the conventional flow there.
so if you use conventional, it would make sense. So that's kind of how I look at it. It's, okay, just like with the diode, the arrow shows the current flow in conventional. Just like this is then named, we can say the collector, the side that's leaving, is that would be leaving for electron. But if you use conventional, then that's the collection side, and the emitters the negative side. So collection would be the positive, and emitter is the negative. See what I'm saying there? So hopefully it didn't hurt your brain. What? You're crying back there. He's whimpering. No, make it stop. All right. Let's see.
Can you go up real quick?
Yeah. What? Oh, go up.
Yeah. Perfect, thank you.
All right. And then what I'm going to say next is mostly just sort of the opposite about that. We have the PNP. PNP. It is. What did I write? Oh, I didn't have something cute. I just put base is the N type. Base is N type. Collector and emitter are P type. They are used as, transistor can be used as a switch. So used as a switch or solenoid, if you will. Let me think. Oh yeah, used as a switch or solenoid. Do I have that here? See what drawings I put in here. Not pointing in, pointing. There we go, just like a solenoid. No, I don't have to write it, you can write it. Where you recognize this thing over here on the left. It's a good old-fashioned relay called a solenoid. So now you see where it comes from. So we just got a switch that activates the solenoid, which then pulls down the relay contacts, making it a relay, and there we go, the lamp is on. Well, now we're doing the same thing over here. Is this an NPN or PNP? PNP. So if I did this and this and this, so it's pointed in PNP. Maybe you can see that PNP. So we think about this, and we learned, like watching the video, that forward bias is on, reverse bias is off. You had to have a certain polarity to turn the whole thing on. And if you look at it this way, I was kind of able to make it make, I think, a little more sense. Let's see if we can get a different color here. So we look at, and how do they have it? Emitter, collector. So this is usually the positive side. Well, that's obviously the negative side. They did that. So we have the emitter on the, and the collector on the negative. It seems backwards than the video we just watched, doesn't it? So now this would be more of a, yeah, it is backwards from the video we watched, isn't it? Because the way they've got this going is the collector collects the negatives and emits out the, go figure. All right.
I was going to say something earlier about that.
About the video?
Let it go.
Well, go ahead.
The names of emitters and collectors, it depends on the configuration.
Okay, thank you.
It's just one of those things you either memorize or you don't.
All right. Well, okay, appreciate that. Well, let's look at how this would work. So what we need to have happen is we need for, how do you want to go? We'll go positive and negative. We need current to flow, positive and negative. We'll go conventional on this today. So how is this going to work? Well, we have a negative over here. And because it's positive, the P and the N, what does the base need to turn on? And this is why I draw it this way. And so I look at those, the P, and the N. The base needs a what to turn on? A negative. All right. So if we turn this on, is it's going to get from the battery up through here, is it going to get a negative? Yes, it does. And so we need this to be forward biased. So it goes negative, the color. It gets a negative, so it turns on, yay. And it is forward biased. So if this were a diode, this section right here, if this were a diode, I should probably make it way bigger so that you can actually not have just scribbles up there. If this were a diode, it is in fact negative bias, yes? That turns the whole thing on. So if that's negative bias, then that is going to turn on the entire transistor, and now the transistor is going to flow through, or flow through this way, whichever you want to look at it. It'll flow through because it is on, and it does work. Follow that? Let me do that again.
Yeah, you do it again.
Yeah, maybe we'll do it nicer. Let's see. All right. So what we had was made the transistor. This particular one was an NPN. Nope, it wasn't. It was the other way around. Oh, I could have stuck with it, so. Had the negative here, so that meant that was a PP. All right, so there's my, all right, there we go. There's a transistor. We'll just do it like that. Had a little switch here. Went to negative. This side was, I'd have a light on it or something. Yeah. Okay. There's the load. And then over here we had the battery. There, that was everything. All right, so, and we're making a relay out of this. So what do we need to turn it on? Well, the on function is always going to be down here, the base. This is the base down here, base. So there's my on function. And so I just look at that and go, well, what letter does that have? If it's got an N, it needs a negative. If it has a P, it needs a positive. All right, so it needs a negative to turn on. And then I look at it and I kind of think, okay, well, let's make a diode out of this thing. So this is my diode section right here now, because a diode only has two sections to it, right? So a diode is either, it looks like this, or turn it upside down, looks like this. That's a diode. It's only got the two junctions, or one junction, two halves. So there we go. So in this one right here, to turn it on, we need to put a what on this side? All right, so this would be forward bias this way, and this would be, you know, that's on. This way is on. This way is. So they're both forward biased, right? Both of those are going to work?
Yeah.
Okay, so then we just kind of take this NP over here, and I'll just kind of take it and just turn it right up on there. Right? This one just kind of comes, just goes right there. So we want to turn that on. If we turn that on from the base going up, then this is on. It's forward biased on. And if this is on, then current flows.
Okay.
So, oops, got to close the switch. Close the switch. There we go. Let's think. Boy, if we turned it around, and we had N, P, N, right? We want to make this thing work.
We need a battery on the bottom.
Yeah. What do we got to do to make it work? Well, they have to kind of look more like this. Right?
Mm-hmm.
Like, would that work? There may be a problem with that because it's there's no negative there.
Yeah.
So I got to put the load on the other side. Maybe put that there. That would work. I might have screwed that one up. But, okay. Go back to this one. Yay, made that one work. All right.
Kevin,
Yeah.
how do you figure out polarity of like a transistor component when you have one in your hand?
Oh, man, I should have wrote that down on here. All right, so how do you figure that out? I can't believe I don't have that on here.
Put like
Yeah, you can't. Well, one thing you can do is you can use a voltmeter and figure out which way is forward bias and which way is reverse. The other way is that they're always marked. So, I know. How are they marked? So, a diode is, well, if it's diode that looks like this, you know, with a wire sticking out and a wire sticking out, you're going to hope that somewhere on there you can see something that looks like that. All right, then you know. Well, if it's all faded out and missing, kind of good luck on that one.
just change it out.
Just change it out. But, like it's an LED, one leg is longer than the other. And the longer leg is the, good, because I forgot, positive. All right. Well, what happens if you cut them both off?
Plug it in, see if it
Well, then you got to get out an ohmmeter or a voltmeter and check it out.
Attach it to the battery.
Yeah, just look it up.
Just-
Just attach it to the battery, let it blow up, and get a new one.
I can't believe nobody tried that. Just put some safety glasses on. Well, you should have said we got plenty of them.
It's cheaper than fuse.
Yeah. Let's see.
Can we?
Yeah, I don't care. I got enough of them.
Alright, go across the street, get an LED. There's a
Bring my
battery.
battery along.
They're
Hook it up to a 12 volt.
base nomenclature. What is the base? This is the controlling circuit. This is the controlling circuit.
What is that?
Base. It's the controlling circuit. You know, I've got on here emitter. I'm just going to drop it off. Emitter emits electrons into the core of the diode, where electrons either flow into and then out of the base or flow into the collector and out. I'm just not going to put that because I think that's not going to help at all. So let's go connection. Connection. All right. So obviously they have to be properly connected to work. So must be properly connected to work, to operate. And this honestly it's this little section where I kind of had to think about that little drawing and come up with that drawing and have it make sense. Because this right here, without that, this started to not make sense, and it started to just be like, what's going on over here? So, so emitter to base junction. Emitter to base junction is forward biased. And if we go back, I'm going to do this kind of slow so that we can sort of look at what's going on. Let's get rid of all that. And I just wrote the emitter to base junction is forward biased. So I said we got to connect it right in order for it to work. Base to emitter junction must be forward biased. What does that mean again? On.
It's got to be on to work.
It's got to be on to work.
Since when?
And in this particular case, this section up here is the emitter. Is it a P or a up here? It's a P. Remember, it's pointed in. So that's PNP. Pointed in, pointy. So that makes this the P. That makes this the P. That makes this the N. So forward bias means that the base has to be negative. That's all I'm saying. So emitter to base junction is forward biased. So in this particular case, we had, let me see, where am I here? In an NPN, so an NPN base is positive. And emitter is then negative, or more negative. And the PNP emitter, I'll write it the same way. Base is negative. And emitter is positive. All right, and the base to collector is reversed. That is in the end. I'll put this, then we'll go back and look at it. So that is in NPN, the collector. So NPN, what does the base have to be? Positive. So in an NPN, the collector is more. Remember, it has to be reverse biased. More positive is more positive than the base. And in PNP, I wish I would have worded it the same way. The PNP collector is negative in respect to base. So collector is negative in respect to base. In respect to base. If we wrote it the same way as I wrote the one up top, what would that look like? So I would have said in a PNP, the collector is more negative. More negative than base. Let's see if that holds up. Because if we go to our drawing, I'll come back to that. And what we just said is, and this is a PNP, and so I said in a PNP collector, PNP collector over here, collector is negative in respect to base. Is negative in respect to base. Okay, so, or then I said, what was the other thing I said? See if it holds up. The collector is more negative, so more negative than base. Does that hold up? So we have it on. And we have a forward bias. This is negative, that's positive, so this thing is on. But then we have reverse bias, where this is negative, and this is going up to, is that more negative? Well, how can we picture that as being more negative? Looking for suggestions.
It's upstream from the loads.
It's upstream from the load, so with respect to the load, like if we had a voltmeter here, this would be the positive and this would be the negative. It'd be the red lead over here and the black lead there. If I wanted to check the voltage drop across the transistor, and I put a voltmeter on here, the red lead would go to the
switch.
emitter,
Breaker.
and then the black lead would go to across the whole thing. Collector, yeah, so we'll put that over there. If I wanted to do emitter to base, it would be the same thing, emitter to base. Well, okay, let's just take a look at that for a second. So would there be a voltage drop here on this one?
No.
Theoretically, no.
Theoretically, no, actuality, but there has to be something because we got to make it, the collector has to be more negative, right?
Correct.
So how are we going to get there? Come on, Tom.
You have to bias your base.
You got to bias your base. Right, so the base is negative. I'm just trying to think of an easy way to explain this and make it kind of work. I guess regardless of what I wrote, the way I look at it is going back to this. The way I look at it. All right, so we've got the P and P, but this is going over this way. And so this branch over here, what does this branch here mean to you? Is it positive or negative? So I look at it as being on the negative side of everything. And so you can look at it, I guess we don't have to make it difficult. Just to say, well, the N, the base, is got negative, right? And the P up here, it also has negative, so it's not working, right? It's not, I would say it's just not really well forward biased maybe. Or maybe don't worry about it and just look at this one and know it'll turn on because that's just the way it's wired. I think I kind of like that idea.
Or you have to put a little battery on the base to adjust it. So
Oh yes, you do have to put power on the base though. It's got to get, well in this case it's the negative.
Unlike the diagram, which is grounded.
Yeah, that's kind of weird how they did that, but I probably would have been better off not using that diagram, but anyway. All right, I don't want to leave you confused, so we can kind of,
So how
did I?
How does current flow through this?
How does current actually flow through?
Yeah.
Okay, let's clean this up, back up just a little bit, and let me think.
I just imagine it as the relay closing.
I do too, but I want to make it in such a way that would make sense here.
Think of the base being the connector all the way across.
Yeah. So, and this will get you through this. So going back to, and that's, hopefully you don't mind that this is not technically correct. So we got the P and P. So when I look at the base to emitter junction, base to emitter, that's my on circuit. And if I can get current to flow from the base to the emitter, if I can get current to flow this way, it's going to be on. And if it's on, then current is going to flow through these two the way I want it to go. So just regardless if you're thinking conventional electron theory, just to keep all of that, see if we can push that aside for a second and just say, if I can somehow turn on that base to emitter junction, the whole thing works. Everybody follow that? Does that work, Tom? Yeah. Okay. Are you electrical engineers? I forget what you did.
I studied that in chemistry.
Yeah. Okay. So Tom knows what he's talking about up here. So he's keeping me straight, sort of. Yeah. So all right. So if we can just keep the base to emitter straight, like a diode, and you guys all know how a diode works, right? One way's on, one way's off. So we just look at this base to emitter junction, and if I had to draw a little diode in here to make it work, well, because I've got the negative there, I would have drawn the diode to look like this, yeah? And so if I can draw the diode to look like that, and I can say, well, if this is negative and this is positive, this is positive, this is negative, I'm saying the same thing, then the whole thing is on, right? And if those two things are on, then I got power flowing this way. My P's are going to turn on all together, and they're going to work just fine. Because really the end doesn't fall down here below it, it's in the middle between the two. It's actually up here.
Just like a digit.
Yeah, it's kind of what I did. So there we go. So that's why I said sometimes when I start writing this stuff out, it starts to be all kind of convoluted, and people go, wait, what happens? What's going on there? So yeah.
Can you do that kind of example but with the NPN?
Yeah, I was afraid you were going to ask me to do that, and I was going to screw it up. Okay. Let's go. All right. I actually have examples. I just wasn't paying attention. Let me see. Which one is this one? That's the same one I drew before. Oh, there's a good one. Okay. So we want to do one with an NPN, right? Not pointed in. So, all right. So not pointed in. So we got pointed out. So there we go. We got the emitter, the collector, the base down here. And so let's see. We'll put this side over here and make some sort of source. And then, oops, yeah, it does. Looking at the wrong drawing. All right, we got that, that. And I brought this down around here. And this comes down here and goes to right there. So variable resistor.
Sounds good.
All right. And then this can go down to my load. There we go. Which, actually, let's not do that. Do this. Be consistent. There we go. Aha. All right. So there we have that. Yep. Okay. These are called biasing resistors, which help to actually set the bias up and give you some control. And we'll show that in a little bit. So let's take a look at this right here. So I'm just going to draw this right over here. So we've got my three boxes, and we have a N, P, N, right? So what do we need on my base to turn it on? Positive. Do I in fact have a, what do we need on my my emitter to turn it on? Negative. All right. So we need a positive and negative. If I get a positive and a negative here, then I've got, we'll say current flow.
Action.
We got action. So, do we have a negative? Yes, we do. No doubt. Straight off the negative side of the battery. This is off the positive side, although we're going to have some voltage drops. So if this was 12 volt, well, it may not be 12 volts when it gets here. It may be 1, maybe 2, maybe 3, 4, maybe 12, 11.5. But anyway, this over here is positive. So if this is positive, this is in fact positive. If this is negative, and it is in fact negative, is this forward biased?
Yes.
Yes, it is. So current's going to flow. And so that means that
On a crank.
through the N and the N, we've got current flow. All right. Let's keep it simple and succeed. There's all kinds of different drawings over here. Yep. All right, go back to this. Nope. Back here. It's all right. We got all that? I don't think we need that. like the drawing better. Everybody's good? Everybody's with me? All right. What's next on the old agenda here? This next point, I'm not going to necessarily write it because we've already covered it at one point, and I really think you guys understand it. But it's going back to this concept of more negative, less negative. There we go. More negative, less negative, which we covered, I don't know, at some point. We talked about where A is positive, correct? That's absolutely positive. It's on the positive side of the battery. C is negative because it's on the negative side of the battery. But if you're checking voltage, right, across A, then this is the positive and this is the negative. And so this is going to be the red lead, right? And the other side is going to be the black lead. But, so that means A is positive and B is negative. But if we turn it around, I want to measure the voltage of resistor 2, then this suddenly becomes the positive. So wait a minute ago it was the negative, now it's the positive. So C is an absolute negative, A is an absolute positive, but point B is less positive. Or less positive if it's 1, it's more positive if it's 2. Or less negative and more negative. So it's just, you have to be careful with absolutes. So when you're looking at transistors, you're going, well, wait a minute, that's on the positive side. Or wait a minute, that's on the negative side. Well, it's maybe sort of in the middle. It's what is it in reference to something else. No. All right, so what do we do with all of this stuff? Let me see. Let's go to, we did that. Is that the one I want? Yeah. All right, so transistor dimming control circuit. So this is a typical light control circuit with a dimmer. See, I screw around with this thing and I just pulled the tip out again, but this time I found it. There we go. All right, I can make the notes here, so if that's helpful. So this is an NPN. So this is what? I just told you, but I mumbled it, so maybe you didn't hear me. NPN, all right. So the base must be, what to turn it on? Positive. And how do you know that? Because the P's in the middle. All right, the collector must, let me see, we'll just go emitter. So the emitter must be negative in respect to what? In respect to the base. And collector has got to be reverse bias, so technically it should be a little more positive. All right, let's put that there. So collector must be more positive than base. All right, so now we're getting somewhere. So base must be positive, emitter must be negative. All right, so let's kind of look this thing through here and kind of dissect what we got going here. All right, so there's the positive, there's the negative. So we can come around here and we go, well, I would say the emitter is full-blown negative if we go that way. And collector over here, it's got already a little bit of a voltage drop from the light, but kind of leave that there. So my base must be positive with respect to the emitter. So on the positive side, we've had a voltage drop, we've had another voltage drop, but is that positive with respect? Mm-hmm. All right, positive with respect. Collector must be more positive than base. So now we'll take a look at that one. Is the collector more positive than the base? It is, assuming that L1 is not some dramatic load right here. And so that is where we get these biasing resistors. And what are they doing? Well, they're kind of knocking some of the voltage down here so that the collector is more positive than the base. So then it works. So what do I got here? Emitter. Yeah, I wrote all that. P1, P sub 1 is a potentiometer. Potentiometer is also called a variable resistor. Variable resistor. In this particular thing, this would be pilot controlled. Pilot control. Pilot control to do what? To dim the lights is correct. All right. So moving the baseline towards 3. Moving the baseline. This is the baseline right here. So moving it towards 3. So I guess it's time to go. Should we pick this up tomorrow?
Yes.
All right. Pick it up tomorrow.
Pretty break. Mañana.